Hi, Brian.
Hey, Jin, how's it going?
Good.
I see we got 11 so far. Maybe wait for people to filter in a little bit.
Yeah.
So I think for the first issue we're gonna talk about is the time window for suggested bit rate. So that's Anoop who is running that one. He is here, correct? Um, for the second one, it's going to be the client initiated signal. Who's leading that one? That discussion, is that going to be? Are we going to pick on Marcus again?
That's all right. But I'm also happy if anyone else wants to lead it. It's all
Okay.
good. Yeah, can take it as
Cool. So we're
Okay.
Yeah, go ahead. Yeah,
So
let's
Brian,
go.
I think we can get a start. Yeah. It seems there's some delay, from my side. Yeah. I don't know. Yeah. So hi everyone. So welcome to our SCONE. So this is our sixth virtual interim meeting. So thanks for everyone to manage to come to this meeting. So I missed the previous meeting due to the travel conflict. Sorry about that. So this session will be automatically recorded by the using the Meet Echo tools. So as long as we're using the Meet Echo tools, so this session record will not be forgot. Yeah, my slides got some delay. Okay, note will apply. So these are about IETF policy, IETF process and rules, cover internet standard process, working group process, code of conduct, copyright, IPR. If you haven't read it, and please take time to read a list of the PCP in these pages. The working group status, and as we know, we already set up 2 work streams. One focused on semantic content, the second is focused on framing and syntax. And since Bangkok meeting, we already have 3 interim meetings. So this is the 4th interim meeting since Bangkok. So we made a good progress for the framing and syntax work stream. Yeah, document status. Actually, we have a very, very important milestone. We achieved this milestone. Actually, SCONE protocol proposal has just recently got adopted as a working group document. The version number is 00 version, and which emerged from 2 important proponents' proposal. One is chain, the other is SCONE quick extension, and so this, actually, thanks for everyone, continuously engage for this discussion. Without your support, we cannot get here. And during the adoption call, we receive sufficient support, both from the interim meeting and also from the list. Also, we have one debate on one of the issue which will be discussed today. And All the open issue will be tracked in the working group GitHub. Meeting administrator, and since we all using the Meet Echo client to join the meeting, otherwise we not get here. And to make sure we have productive discussion, and please make good use of this Meet Echo resource. Identify yourself before you speak, and then mute your video and audio if you do not involve any conversation. But you do involve any discussion, please unmute earlier, because there's some lag for this unmute button. And we also have Zulip tools, which has already been perfectly integrated into the Meet Echo as a chat windows. Please help to keep an eye on the discussion in the chat window and relay critical discussion to the meeting room. And we also need a volunteer to take notes, and we share the notes link in the chat window. Please help. And
yeah, I can back you up on that.
Yeah, okay. So this agenda for today's discussion, I think we will spend most of the time on the open issue discussion for the SCONE protocols. Two fundamental issues, as Brian already mentioned. The first two is time window for suggested bit rate, and is issue ticket 20, which will be led by Anup Tumar, and he will have some lab test results to share. So we look forward, for this good discussion. The second is client initiate signal, and I see Marcus has already summarized what has been agreed and what hasn't been agreed in the GitHub. So I hope we can, have good discussion on this as well, to better understand the pro and seems none. And so Brian, do you have any comments?
No, I think we can go straight into the open issues discussion. So yes, Anup, you are now up.
Okay.
Cool. So Quinn, are you going to share the slides, or should I share it?
You want me to share, or you want to? I can pass the control to you. Or...
Okay.
Let me check.
Yeah, I already passed over. You should be able to. Did you see that, Anup?
Yes.
Yeah, good.
Okay.
But how do I share that? Do I need to click it, or do I need to share screen? I'm doing it for the
They
first.
They should have been uploaded. Did we put your slides in? Did we upload those to the data tracker? If not, then you can do a screen share.
Yes, we already share.
Okay. So it should be in the. Yeah, there we go.
Yeah.
Good.
Cool. Hi all. This is Anup from Meta. So today we plan to share some data that we have got from our lab experiment. This is like we have run some data in the lab to understand how different applications send data over wire, to understand what can be the reasonable value for time window for bitrate measurement. But before we go there, I will set some context for the people who are not following this issue. This is basically issue number 20 in GitHub. So for the benefit of people who are not tracking this issue closely, I will spend some time to set the context, and then explain why we decided to run some lab experiment, and then we'll share the lab results. And based on the lab results, we'll share some recommendations based on the observation in the lab. So just to set the context, if I think this topic was discussed in last working group also, and there is a discussion happening in the GitHub issue number 20. The topic is basically that when the network element sends the advice bitrate to the application endpoint, the application endpoint is supposed to do the bitrate adaptation, and then network element is supposed to stop doing the throttling or shaping and policing. But the network element is expected to do some kind of conformance measurement, whether the application endpoint is conforming to the suggested bitrate, so that it can keep the throttling off, or if the application endpoint is not conformant to the bitrate that is advised by the network element, they can bring back the policing or shaping. So that is the overall context here. So the main aspect is, it is important that there is a clear understanding between client endpoint, application endpoint, and network element, how this average bitrate is supposed to be measured, and the time window duration to measure this average bitrate that is suggested by the network element is one of the important aspect of overall bitrate measurement. So in today's presentation, we plan to address only the time window duration aspect of this bitrate measurement. So we have put some TLDR, like this is an overall summary of the entire presentation, but we'll discuss more details in subsequent slides. So first point is, as all of us know, the video services, mostly we are talking about on-demand streaming services. They are bursty in nature, and they are supposed to be bursty in nature because the way the video services are delivered over the internet, because the short form videos, streaming videos, they are supposed to be very responsive to users' expectation whenever they select an application, like short form application, any videos. The expectation from the user is the video should start playing as soon as possible. There should not be any stall, and this expectation becomes very high when we are talking about the short form video compared to long form video. So that makes video services supposed to be delivered in a bursty nature. And we have made some, I think this is also well known fact, that bursty traffic profile is good for quality of experience. As I explained, it is going to have a very good responsiveness from the user experience point of view. And and the RAN, from RAN scheduling point of view also, this RAN is radio access network. I'm referring to mobile access network. The scheduling of data for video on demand users, the traffic is bursty. This is good for the scheduling efficiency for the radio access network. Basically, they can utilize their radio spectrum both for data channels as well as for control channel in more efficient manner if the traffic is bursty. So this is the overall, I think, background why this is important to have a reasonable window duration for the video on demand service applications. So we have run some experiment and we'll share more details. But the key observation from the lab experiment is the current time window that is mentioned in the draft document, 20 seconds, is way too low, and it can be very restrictive for video services. It basically it is going to curtail the burstiness of the traffic, and that will in effect is going to impact the QoE as well as the RAN scheduling efficiency. And just to add to that, we have done some experiment in the lab in past, and we have seen the burstiness helps with the UE power saving also. So basically, it's going to impact the UE battery power also. Uh, and the second observation that we made was that the time window duration that meets the advised bitrate is not a one value that fits all the advised bitrate values. So basically, it's a function of advised bitrate value. So if, for example, if you're suggesting, if the network element is suggesting a very high bitrate value, a smaller time window duration is okay to meet that advised bitrate. But it's a function of the advised bitrate, and you can see that once we present the results. The key takeaway from the experiment is that 120 seconds seems to be a reasonable value, and we'll explain why we are making this statement, and then we can go into more details. So again, just to the level set the room here, we have put this slide just to explain what is the context and what is the problem statement, and why we are making this presentation, and what we plan to discuss in this presentation. So as we all know, even though it is not well defined, specified right now in the applicability and management document, the expectation is how SCONE is when it is deployed in the network element, how it is supposed to be working. So application is going to support, this is issue number 5 that we are discussing, indicate support for SCONE, and network element sends advised bitrate to the application point. Application point is supposed to self-adapt the advised bitrate, and the network element does not rate limit the flow. So this is the overall high-level flow. And then network element, they are supposed to measure the bitrate over a fixed duration averaging window to verify the conformance. So the problem statement here is what should be the duration of time window which is acceptable to caps as well as to CSPs. Basically, the average bitrate measured over 1 second is a totally different ballgame compared to the bitrate measured over one hour. So it is important that we find a right time window duration so that it is not very long also, because if you keep it very long, it can be abused, in the sense can be used by the application provider to send very, very high bursty data for very small duration. So, and it should be long enough so that it does not restrict the video services and keep the burstiness to meet the QoE expectation from the subscribers. So there is a issue that is being discussed in issue number 1. So you can look at it offline. And as I explained in the beginning, streaming applications are bursty. Basically, the data, the way data is sent over the wire is there's a data burst followed by idle period. So, and it is good for the QoE, it is good for run scheduling efficiency. So this is kind of the context. The problem statement is uh, different applications, they may have different preference for video window length depending on their burst profiles, depending on their prefetching overfetching strategies, depending on the playback buffer size. They may have different kind of burst profiles. So if one window length is good for one application, it may not be good for other applications. So we have to find a window which is acceptable to working fine for all the application as well as acceptable to CSPs. And as I mentioned earlier, the current value of 20 seconds based on the experiments seems to be very restrictive for video services. So we are trying to find out a window which is going to accommodate all the applications, but not too long. Now, if you refer in the issue number 20, there are different options that is being suggested, which can become a basis to define a time window duration. RTT is one of them, but the challenge with RTT is, so basically we have looked at all these options before we decided to run some lab experiment. So RTT basically it ranges from tens of millisecond to 100 millisecond. It depends on different networks. For mobile network, RTT may be different. For satellite network, it may be very high. So it can have a wide range. And again, it's a very small value and can be very restrictive for video services. Same thing is video segment size. It is a variable segment depending on different applications. And it can be also very restrictive because it's a very small value. We have considered using video playback duration, but again, video playback duration can have wide range, ranging from 60 seconds or smaller to many minutes. So the key point here is none of these points can have a very solid reference point to help decide a time window duration. Either they are very small or they have wide range. And sometimes application may know the video segment size, but the CSP may not even know the video segment size. So overall, we found it challenging to use any of these aspects to make them as a basis to define the time window duration. So what we decided was to run some experiment in the lab, see the traffic profiles over the wire, and try to use that as a basis to define the time window duration. So this is the way we have done the experiment in the lab. So we have put together a lab to simulate our mobile network. So this is a real mobile network. Only thing it's in the lab setup. It has a real eNode B and the packet core connecting to the UE, which is hosting the application, connected over the RF cable. And basically we have used LTE FDD setup with 5 and 10 megahertz bandwidth and good channel conditions. And we have used top 4 used video on-demand streaming applications, short-form applications, 4 of them, and we have run them one by one in sequential manner so that we don't create a competition for scheduling for these users. And then we have captured the PCAPs on SGI and N6 interface. Basically, this is the interface where right now the network element are doing throttling or shaping or policing. So we thought of this is the right point to see to capture the PCAPs and see the traffic profile and how these applications are sending the bits over the wire at that particular point of time. And then we calculate the average bit rate for each app using different averaging window values. So this is the observation, and then we'll share the results. The observation is, as I mentioned, this the averaging time window duration is a function of advised bitrate. It does not like one value is not suitable for all kind of advised bitrate. Again, as mentioned earlier, it is application specific, so that was expected. And we also tried to do the averaging using block window averaging and sliding window averaging. Basically, what we did was we calculate the average bitrate over a window and then slide the window by 0.01 second. Basically, there is a partial overlapping between these two windows to cover all the different starting point of the averaging window. And the second way is block window averaging, where we have not done any overlapping. So for example, if you have taken a 20-second window, we measure the average bitrate over 20-second window and then slide the entire window completely by the 20 seconds. There is no overlap. So we have used these two methods just to understand, do we see different results, and we'll share those results. So this is a block window averaging. So if you see, there are 4 apps. These are like on-demand streaming short-form video apps, and we have collected a bunch of data. We are just sharing to keep it simple, small sample data here, and we have used different advised bitrate starting from 10 Mbps to 1 Mbps, and we did the measurement using different window size. So these are the window size which are there. So the way to read this table is, if I use 10 Mbps as an advised bitrate, then for application 1, for all the application, 20-second window size is good enough to meet that advised bitrate. But if I go lower, suppose I take 2 Mbps, then the common value, if I say approximately 120-second, if I use 120-second window size, all the applications are going to meet that advised bitrate, because if they are meeting with 60 second, they'll be able to meet with 120 seconds. So the larger is the window size, is easier to meet that bitrate, advised bitrate. So if it is 60 second, that means 120 second will also work well for that application. So if you see you can observe that lower the advised bitrate, the longer the required window size. And if you consider 1 Mbps as a baseline bit window, the duration has to be more than 120 seconds. We have not done the calculation what exactly this duration will be, but because we wanted to have some kind of some reference, so we have used 2 Mbps as a reference, and 2 Mbps has given us a reference where like 120 seconds seems to be a window size which works for all the applications in current form right now. And if you go below than that, then for some application 120 second works, but for some application you need larger window size. Same experiment was done using sliding window, and the key point is we don't see there's slight changes in the window size, but it is not significant enough to to see, okay, the sliding window is making a significant difference in the results. So they are like giving the similar kind of results, whether to use sliding window or a block window. So again, finally coming to the recommendation. So the 120 seconds seems to be reasonable value, and here we are just using 2 Mbps as the advised bitrate. If we have to go below 2 Mbps, either application has to do some optimization, or we have to increase the window size. So basically, key point here is 20 second is very restrictive. 120 seconds seems to be okay if you are using 2 Mbps as the advised bitrate, and then it can be a minimum value. and if required, the value can be larger than that. But if you are looking for a minimum value definition in the protocol document, 120 seconds seems to be a reasonable value. And another reference point, even though it is not connected with the topic, what we observed is in net UDP. So this is the RFC for how net is supposed to be configured. We have observed that there is a mention of the timeout value should be minimum 2 minutes. That means this is accepted that the application may not send any data for at least for 2 minutes. So this is kind of aligned with what we have mentioned at the beginning. The application can be bursty, and they can have the traffic profile where you have a burst and then there's no data transfer for significant period of time. So this is kind of consistent with what is mentioned in this RFC also. And there's one thing that we observed. We think that there is a need when we are doing this calculation and experiment. I think it is important that CSPs specify the overall mechanism to be used by them to measure the bitrate on the network element, maybe in applicability and manageability document, because once they do this, everything window will start making more sense, and we can add more information to it, and it can be complete information available how the CSPs and CAPs are going to measure the bitrate, and because this is an important aspect of SCONE deployment. Thank you.
Cool. Thank you very much. Are there any questions? Okay, Marcus, coming up.
Hi. Yeah, thanks a lot for doing this work. I think this is super great. This is exactly what we need. It's much better than just guessing values. So I'm really happy about that. And to me, yeah, 120 seconds sounds absolutely reasonable. I think my first guess was 60 seconds, so it's in some similar ballpark. A little bit curious. You didn't see much changes or difference between the sliding window and the block block method. So the question is how, and then you talk about this open issue that we need to specify the mechanism. So the question I have is, how detailed do you think we need to specify this, given that this is something that will, I mean, I understand we should have some level of guidance here, but this will be something that is not enforced by a protocol. It's something that will be implemented in network elements, and they might do different things regardless of what we write. And you also show that the difference between a block and a sliding window here is not that big. So like, what is your expectation of like?
So from sliding and average and then the block window, I think the CSPs, the significance from the CSPs standpoint is if they really care about when they are, like, what is the starting point of the window. So suppose we fix the window duration is 120 seconds, but are they planning to measure this bitrate randomly at some point in time, or they want to make sure that this window is starting at a specific point? So if they are particular about window start point, then they should go after the sliding window, because that way they can capture all the starting point because there's overlap. But they want to randomly capture the bitrate at a random point, and the blocking window average. So again, so that's why it is important as CSPs to specify that what is their expectation when they measure this bitrate, and that is going to help us whether they are going to use block and the sliding window. Coming back to the second point, to what extent CSP should define this mechanism, I think it is important for CSPs to specify that they will do it for per flow, and because it will take some effort from their side to measure this so frequently. So if they come back and say, we are not even going to measure at 120 seconds, we are going to measure for 1 hour, then this discussion about time window duration becomes less important. So how much time we should spend on defining these values will depend on how CSPs are going to measure this bitrate on the network element.
Thank you.
Dan, go ahead.
Yeah. Thanks, Anoop, for putting this together. Quite useful. And coincidentally, I just opened an issue yesterday because I feel like we're lacking some details about clarity on what the advice is. And the draft that I have on the video session data rate captures some of the aspects that should explain that there's an aggregate amount of data that goes over the wire. And I explained there actually that we only see um, bits on the wire, so we don't know what they are. So measuring is an important part. But I think the draft that I it's about to expire, and I don't plan to renew it. It could be split between defining what the throughput advice is and how this window fits, as well as some of the explanations on how can be measured can go in applicability and manageability part. But in any case, I think it is important to emphasize that we're looking at aggregate bit rate on a 4 tuple because that's the only thing we see um, on the wire.
Sounds good. And I think it'll be good to specify that so that, because right now we are assuming that it'll be per flow measurement. So if you think it's aggregate, that might change things. So it'll be good to specify. And that's why we have put this as a request that if you can specify. And so right now this everything window discussion happening in the context of the per flow measurement because we are talking about per flow. So yeah.
Yeah, but with the Pearl flow, it can encourage cheating, right? I mean, if we set a certain throughput advice, but you're generating 20 flows, then that's not exactly what our policy is about. So plus, it will be difficult to measure on the CSP side. So that's why I think we need to do a little bit more digging into this and see not only what is ideal, but what is actually doable. Right?
Yeah, sounds good.
Thank you very much. Kazuo.
Hello, thank you for presenting this. I agree with that this is super useful and probably we can use this as a basis. I have one question, and do we know why it takes more time to adapt when the bitrate is low?
So this is not about adoption to the bitrate. We are talking about when we are measuring this the flow over the wire. If you look at the burst profile and then idle period, when we use different window size, what is the average bitrate? So we are not focusing on how fast applications are adopting the suggested bitrate. So basically, the bitrate has been advised, and now application is doing adaptation, and the network element is going to measure it. What is the time window over which they should measure this average bitrate?
Right. But if you go back to the table that you show, it said that as the lower the bitrate goes, you need a longer time window.
Yeah.
Right. So I think my question is, do we have a good explanation why it behaves as such? Because I mean, the current minimum of the bitrate signal is 100 kilobits, if I recall correctly. So if we see the same trend, maybe it takes like 1,200 seconds in case of 100 kilobits, and it essentially means that we cannot use SCONE for that low bitrate. I mean, it could mean like that. So I'm just curious if we understand why and if we could fix that if necessary.
Yeah, it's a good point. We just observed the behavior and then it was presented. Why it is happening is a good question, but we have not looked into that part.
I see. Thank you very much.
Ian, go ahead.
Okay.
John, did you have an answer to Kazuo's question? Because if so, then
Yeah, I was. Yeah, I mean, I could propose a theoretical. So since John was saying from YouTube, I could propose theoretical reasons why I think lower bit rates would have these longer time frames, if that would be helpful. So hypothetically, like in sort of video serving, right, with lower bit rates, you can get longer amounts of content time for lower bit rates, right? So I can download 2 minutes of video at that low bit rate for the same amount of bits as as something as a higher bit rate. So what we're saying is I can download 2 minutes of video at that lower bit rate, and then I don't have to use the antenna, I don't have to use the modem, I don't have to download data, I don't have to interfere with other connections, I don't have to initiate a new connection. So it's much more efficient if I can get 2 minutes of data at that lower bit rate, because they don't have to then download it at other times. So hypothetically, I think that is why like video platforms would, at these lower bit rates, have these longer time periods, because we're able to space out those requests, which make it more efficient for users, make it better for the network.
In the most extreme example, I can imagine something like a music service just grabbing the entire song at the beginning. I know at least some of them do this. Anyway, okay. Actually, I want to go back to the last slide. I just wanted to because the open issue, I think, and this is sort of a difficult thing to state, but like one question I think collectively I, John, Anoop, and others had is, are network operators actually going to do any of this sliding window, moving window stuff, or are they just going to look at like all the YouTube traffic as this giant herd and be like, this largely looks like it's compliant, asterisk, in some kind of really bulk aggregate way, and if it's not, then you're going to call us, right, or something like out of band. And if you don't have the energy to call us, then you're going to start throttling us just like you do now. Basically, like I think a larger number is useful anyway, because it seems like 20 is just too darn low for any. I think probably quite a few use cases, but there's this question of like, do we actually expect ISPs to do anything like what we're describing, or are they going to do something like much more aggregate, or is it going to depend on the ISP? And so we should specify something with the knowledge that some people will do it in a specific way and some people will do it in a more bulk way.
That was great. I was going to comment a little bit on Dan's comment, and then I think you posed a really good question that falls into what I wanted to say, that whether or not you do measurements on an aggregate or on a per flow level is not something that we are going to. I mean, we can provide guidance here, but I think that operators will do this differently. They already do this differently. For the kind of video throttling services that are out there today, there are some that only look at individual flows that can easily be cheated. There are other ones that go out of their way to try to aggregate and group flows belonging to a certain application into kind of one aggregate set and do things on that. And I think we will see a similar situation here. I think what we can do is provide good and useful guidance on what makes sense for video applications, and also what makes sense for CSPs, because there will be a trade-off in terms of issues around cheating, like Dan mentioned, and issues around like how complex is it to do the measurements and so on. I don't think there will be one uniform answer, but I think it makes a lot of sense for us to actually specify these windows and kind of give an example method, because we will at least have some operators and some vendors doing something around those lines, and we get something that is a little bit more predictable and less completely random like it is today with the shaping and policing. So I would be very much in favor of doing that. And to Ian's point, like what will ISPs or operators do? Like, will they just measure a huge aggregate and then call up YouTube? I mean, that might happen in some cases. I think what we're trying to achieve here is not that. I hope that we're actually standardizing something here so we can have something that is very much more agnostic and works with all kinds of traffic and all kinds of application services, right? So I think there's large value in specifying it in this way, knowing that there might be operators that just do it in their own way anyway. But I think it should be our ambition to make this make this as clear as possible.
Yeah, so thanks, Marcus. And to Jan's point, like it is important that we understand how CSPs are trying to do it, because right now, if you see the experiment we have run, we have made some assumptions, right? Per flow and then one application at a time. So if they say, this will be aggregate or it will be different way, or they don't care about 120-second window, then we may run a different experiment to, so right now the time window duration is happening, discussion happening in a specific context. If that context is different, if the CSP is not going to follow that methodology, then they should specify it so that we can have this time window discussion in that specific context.
So I think Dan is next in queue, but appears to be having some connectivity issues.
Can I then jump in?
Yeah.
Just, one thing on the context again. I think even though some might look at individual flows and some might look at aggregates, it could still be so that an aggregate set of flows belonging to one. It doesn't mean that I don't think the difference has to be that large. Like if you are a video provider, say YouTube or Facebook or whatever, and you're using one or two connections to fetch your video. If these, like, you do want to measure the video session somehow, and a smart operator might actually want to look at that aggregate set. It might not want to look at all the other stuff that you're sending potentially, but I think that the option must probably be there, and then whether this is implemented that way, I think that will depend on each operator. But I think we need to assume that. And I don't know today, like how common it is that you just set up, like for websites, you might set up 20 TCP connections and fetch objects in parallel. I'm not sure if you do this for video, right? But if that's a common practice, I think this is something that we need to take into account when designing this method as well.
And back yet, no. I just want to follow up, like I think on Mark's and sort of Ian's point about getting data about how an ISP will measure this. I agree. I don't think it's necessary. Ideally, I think we design a system that it is generalizable and it works for any of these. I think it would just be helpful to understand for us to test out this system and see how it is going to work end to end to make sure like we're not missing any holes. That it can be helpful to get that information, just to see how the system works end to end. So that's why I think it's a reasonable request just to get some examples to help see how this percolates through the whole system.
If we're not going to specify whether it's done on a per flow basis or an aggregate basis, do we need to have like a bit in SCONE signal that tells applications what the network element is doing so it doesn't accidentally fall out of compliance?
And utter silence, which means it was a good question. I'm going to throw myself into the queue here because I already put my microphone on. I think there's a question that Marcus just asked that would be super useful to get into before we go down this rabbit hole, which is how common is the behavior of sort of like what I think of as 1990s era Netscape communicator web behavior with respect to video, like parallel video streaming right now, right? Like, so I know that we can talk about, yes, well, if everybody knows that all of these limits are by design going to be on a per flow basis, then you can always game things on a per flow basis, right? Like I don't want to get too much into game theory here because, we only have a couple of hours. But I think the answer to the question of whether we need to signal it is tied very much to the answer of how prevalent do we think this actually is.
Well, I think we either have to specify or just like a matter of logic. I mean, I don't have any particular view of the merits of like either form of modeling, but I think we're going to have accidental non-compliance if we allow network elements to do either and then don't signal it in any way. So I think we have to decide so either forbid either mandate you do one or the other, or alternatively have a signal.
So that seems like a new issue that should be filed to have that discussion. Martin, can you go do that, please?
I can.
Thank you. Kazuo.
Right. So regarding the excellent question that Martin just asked, my 2 cents is that, well, it's not always the case that all the flows belong to one application. So even though we had the signal indicating the granularity, it's not always actionable. So I prefer the signal being per flow basis. That's my high order point. And the next point is that in reality, SCONE is about optimizing the behavior for clients that comply. And I mean, always falling back to policing or rate limiting is the backstop that the operators would have. Considering that, I agree with others that maybe CSPs can calculate the value based on the unit of subscribers rather than flows, and apply, hoping that there's only one flow per user at any given time going up to the threshold. I think that's not a very bad assumption that you'd want to have, and it would work most of the time. And then, considering that SCONE is optimization, I think that's just fine.
Martin, are you still in queue? No, cool. All right, then 2 seconds of awkward silence. The queue is drained. Anoop, thank you very much for the experiments and for leading the discussions. I think this was super useful. One question I'd like people to think about, we're going to address this a little bit more in the next interim probably, is are there experiments / we're not going to get to the point where we could do anything that looks like an interop before Madrid, but if there are experiments or other sort of things that could be in this space that would generate useful input to the documents that could happen at a hackathon in Madrid, think about that and take it to the list or take it to the next interim meeting. With that, we're going to move over to our other favorite issue, client-initiated signaling. Marcus, can you come and walk us through the current state of that?
Who knows what the current state is? I'll do my best. Let me see if I can share something here as well. And I have
We've given you slides control, so
no slides, unfortunately. I was not prepared for this, but we can share the issue. I wrote a summary there, and then discussion continued after that. But maybe we can start it from there. I don't know, or we can just talk. If I can request screen share, maybe.
Yeah, request screen share. Yes, done.
Do you want to share the screen? Yes. And then I can choose what to share. Then I'll try to share that one. Let's see if that works. It does work. Great. So again, trying to summarize the issue for the second time, I guess. But from the previous interim, there seemed to be quite broad agreement in that there's good to give incentive to networks to deploy SCONE, right? We know there's quite clear incentive for certain applications and so on, given the current practices of certain operators and so on. But it's important to find good incentives for operators to do this, because otherwise we might just be designing something that doesn't get used. And early indications were proposed as one such incentive, because that they can really help with kind of TCO issues. Like it's costly to do DPI, and there are operators who express that, you know, having something like SCONE could be a vehicle to get away from having to do costly DPI and heuristic methods to detect specific video applications and so on. So that would be a nice way. The main disagreement up until this point is that what should this indication really imply? So we do that some want this indication to clearly mean that, hey, this is an ABR video flow. This flow can be adapting well to rates, etc. It's easy to skip DPI if you know this, so you can save CPU. And others have expressed a worry that a dedicated kind of video flag becomes a new kind of fingerprint, and that's you know, can be misused in various ways. Like it would be a little bit sad if we design SCONE and the only thing that we achieve is making a new trigger for activating throttling, for instance. Then maybe we didn't achieve exactly what we set out to achieve. So that is a little bit of a concern. And then some discussions have been flying around in various forums, and one suggested compromise to this is that we do allow early indications in the protocol, but we do encourage all flows, video and non-video alike, to actually make use of these early indications, because this definitely reduces the fingerprinting concern. It also very much reduces the incentive for operators to just use this as a throttle trigger, because now you might just start throttling a bunch of flows that you didn't really want to throttle according to your current, or we call them legacy, video policies. So it might actually be a way to get around that issue. And then, well, okay, but if everything sets these things, are indications at all helpful then? And then the point would be that, well, there might still be a period, even though we in the draft or in the RFC encourage applications to or endpoints to set this, there will likely be some transition period. There will be some video services that do this and some that do not. And operators now have the possibility to kind of coexist, have the SCONE rules coexist with their legacy rules, because they probably want to do DPI for a period of time until they're quite certain that most of the applications actually work in this way. And maybe some video applications will never work in this way, and these things need to coexist at all times. We don't know. So there's likely still going to be useful to have these indications. That's pretty much it. And then there is some more discussion that goes on here. For instance, well, if and now Sanjay is not here, so, but it's a little bit worrying from his perspective. I understand that, you know, if you detect all kinds of traffic using this, then there's no longer a video only policy. What does that mean? Yeah, I think that's the question now. Like, what do we do if SCONE SCONE indication no longer just means video? Will operate? What kind of policies will operators apply, and so on? And I think that is one of the discussions here. My personal view, if I may bring it up at the end of this summary, is that I think that this is the right way to go. And I think that the previous presentation, looking at and suggesting pretty long average windows and so on, makes this pretty safe to move from a model where you throttle video only to enforcing long-term bit rates that are a little bit more application agnostic. Because if you're talking about these averaging windows, and a little bit depending on how you measure how you measure the average bit rate and so on, but you are pretty much safe from a lot of from the perspective of a lot of traffic types. Like a lot of browser traffic will be completing in way shorter times than 120 seconds, for instance, and stuff like that. So I think we might end up in a compromise here that is nice. And of course, an operator that really cares about doing this only for video can always resort to its previous policies around doing DPI and still make use of SCONE signaling. It's totally fine to do that, as long as they are capable of doing it. So that's my 2 cents on this. I'd be happy to hear what others think.
Yeah, I just wanted to add that I never saw this as an indication for video traffic, because video traffic, we're handling video traffic or throttling video traffic is our main use case, but the protocol we're designing is just, an endpoint wants to know what's the rate limit. That's the protocol we're designing. So if you are indicating that you're supporting SCONE, then you're just indicating exactly that. An endpoint wants to know what the rate limit is, and this might imply that an endpoint actually, or like the application that is used by the endpoint might actually even benefit from throttling, which is the case for video. But it doesn't necessarily, it's a one-to-one mapping saying this is video. It's a one-to-one mapping saying I'm okay that the network might throttle me, or I might even benefit from it. And as such, I think the advice in the document should be, if you know that the traffic, the application that is running on top of the quick traffic, is okay with throttling or would benefit from throttling, then provide the indication. If you're not sure about this, don't provide the indication, because then it would actually make it easier to say everything that's going, I just throttle it. And I just want to say, I don't think it does change anything, because you could always do that. You could also later, if you see a SCONE package, just assume as a network that if it's SCONE capable, it would also benefit from throttling, and then make a throttling decision based on that. So that's my point of view.
Cool, thanks. I put myself in the queue with my chair hat on, actually, to say something very adjacent to what Mary just said. I read over that charter before this to remind myself of what we're actually doing here. And there's no endpoint to network signaling in the charter, right? Like, so what we are defining, if we end up with a document that's like, hey, and you can use this to figure out where your video traffic is and therefore turn off all your video DPI. I've never been on the IESG, but like in IESG review, I would compare that to the charter and go like, okay, well, you said that you're doing signaling in one direction and now you're purposely doing signaling in the other direction. What gives? All of that said, right? Like, so a flow that advertises that it will be SCONE compliant, right? Like, the contract is I put the SCONE header in, and a network can expect that the application will react to the rate information that is given, right? Like, I mean, like there's always the credible threat of network violence on the back end with the throttler to enforce that, but that's sort of the expectation. Otherwise, you wouldn't go to the trouble. You wouldn't be spending the bytes on telling me that you're going to listen, right? That's part of the protocol's wire image, and I think that there are certainly, enterprising network operators and vendors that will make assumptions. Like, we can say, just because it says SCONE doesn't mean it's not video. Guarantee you that people will say, okay, put this in the video class, right? Even if we say do not do that, right? Because it looks like a shorthand. But I do think that there's a difference between that, right? Like, so acknowledging and knowing, going into this on the front end, knowing that this is in the wire image, versus being very explicit in the protocol that you can make assumptions based on the presence of SCONE signaling. So I do think it's like, that's over the line of where I think the charter is, right? Because
All right. So regarding Maria's point, I agree with Sam and I disagree with Sam. And I think what I wanted to say is that, well, it's often the case that clients don't know when they connect what the connection is going to be used for. And the experiment that Anup just reported indicates 120 seconds, which is pretty safe, I'd say, for any client to say that this flow is SCONE, knowing that it might not be able to comply. So I think we have more probability that we can just channel SCONE everywhere and hope that things would go fine.
maybe unmute then. Dan.
Yeah, thank you. I want to clarify a few things. So when we say video, it really is ABR that we're talking about, not every kind of video. And the reason historically these shaping policies were in place is because when you're shaping, you're expecting that the user experience is not going to significantly drop because the traffic is elastic, right? The client, the player will adapt to the rate that is presumably set by the network artificially, right? So the, so just to be clear, it's not about video in general. It's about elastic video in particular that we're trying to address here. The other aspect is having an early indication is something that be able to classify at a very coarse-grained cloud traffic is something we lost from DSCP due to the gain benefit of assuming quality of service in the network. So it's not something that we're adding a new fingerprinting mechanism. We just lost that on the internet now because we get those bleached at the edges of the network, right? So adding the fact that we are looking neutrally and completely non-discriminatory at ABR traffic, so we are able to measure the enforcement of the policy is actually something necessary, and ideally we would be doing SCONE only for this kind of traffic. So it becomes very difficult um, to make all these measurements on a very generic, okay, I'm going to just send SCONE packets to every single bit of traffic that I'm generating. So that's pretty much what I wanted to say. Hope it makes sense.
I'm joining the queue again to clarify or reply to Kasu. So what I meant to say is that I would like to see a recommendation in the draft that you should not set the early indication if you have no idea what the traffic will be on top that the quick connection is used for. However, that doesn't mean that you actually have to know exactly what it's used for. So, for example, if you have browser traffic, a lot of the connections will be very short and it really doesn't matter if you throttle or not. So you can just send it if you have that kind of knowledge. So all you need to know about the application above is if it could tolerate or benefit from throttling. And if you don't know anything, then I would like to see a recommendation to not set the early indication. That's it.
I would just came in to say that on Brian's previous point before this discussion about things to not maybe interrupt, but like more things to experiment around. I think this is a great thing that we should actually look at. What different average bit rate, average windows, and like what are the consequences for different types of traffic when doing this? If moving from a model that today only tries to single out ABR to something that is even more generic, saying that I might have long-term flow, flow monitoring and flow enforcement on long terms for all kinds of traffic. What does that mean for different types of traffic? I think that would be a very good thing for us to actually to look into to some degree. My take on this is I kind of agree with Kazu. I think that if we have something like a 120-second window, I think a lot of applications would be safe, and setting this indication quite generously would probably be quite safe. I think maybe the things that would be get a little bit sad is things like very large bulk transfers and such. But I guess that's something we could look into.
Ian, go ahead.
Sorry, I'm being evicted from my room. I will get back in the
All right, so I didn't think we were going to come to a conclusion on this discussion, and you know, expectation is the root of disappointment. So no expectations means no disappointment. Let's see, we have 25 minutes left. Are there any other issues that people would like to bring to the working group while we're here to spend a little bit of in-person time on them? Going, gone. Is there any other business that anyone would like to bash onto the agenda and discuss? Ian. Oh wait, no, Ian's in another room, so we can actually go back to your thing. Yes, go ahead, Ian.
Yeah, sorry about that. I'm trying to think about like how it would actually work in practice in terms of like setting it on all flows or the majority of flows or only flows that you know of, so on and so forth. And I'm thinking of something like a browser sort of use case being like trying to walk through that in my mind. I mean, certainly if you had zero RTT sort of resumption information, you could say, well, last time I connected to this SNI, it said it could, although like a given host name can serve a lot of different content. So I'm not even sure that's particularly safe. And I'm just trying to think through, I think the send it on almost everything and see what happens approach is probably actually safer than the kind of only send it on stuff you know approach. I mean, large downloads even like, I mean, if I had like a large download, like I could make my server like be able to cope with this, right? Like it's not impossible. Like if I'm downloading a terabyte file and you say you have to average 2 megabits, like that is a thing I can implement in my server. I don't have it today, but I could do it. They can always set SO max pacing rate or something if I'm feeling lazy. I don't know. So I'm trying to think about like the practicalities of it, and I have a hard time figuring out how to only send the client signal on flows that you know will be able to be ABR'd. I think the idea of sending it kind of on most flows under the theory that either most flows are short enough that they can be ABR'd, or, you know, hoping that longer term flows will downloads and otherwise kind of fall in line and actually adapt and start doing adaptation that seems plausible to me, but I don't know. Yeah. So I just want to make sure we're like trying to specify a recommendation or a policy that we actually think like hopefully a browser can implement, because, you know, losing all browser traffic would be sort of sad here. So that's it.
So I'm going to interpose myself here. In this whole discussion, I hear a lot of sort of tension between the desire to replace DPI and classification of traffic, saying, hey, this is probably video based on SNI, with an early signal that's an implicit signal, you know, based on SCONE. And I think there's a lot of tension between that. And it seems to me, from what we're hearing from a lot of people who are implementing clients, the information that is available at connection establishment time, especially with something like Quick, right, where you're going to establish a connection, you'll have a bunch of streams. You might well into the lifetime of that connection realize, oh, wait, this is an ABRable stream, right? If we're not trying to, as a matter of the protocol saying, you know, you should or must supply the early indication, this would be a should, I guess. You should supply the early indication every time that you suspect that you will be able to react to ABR and will benefit from it. Seems to be at odds with like the way that the dynamics of a lot of this client software works. Like you're not even going to be in a situation where you have a context that the application that's running on top of you can tell you to do that thing. What I think I'm also hearing is we don't like the discussion that we had at the beginning about sort of like the, taking the data that we have and saying, okay, well, the windows that we're going to be dealing with in order to make this work are going to be longer, which also increases the safety for most other traffic, means this becomes a thing that we would do. You would only ever not turn it on as soon as, like, on a flow that you absolutely know is going to be hurt by it. I don't think I'm trying to come up with something useful to do at a hackathon table in Madrid. I will be there. I'm not sure that we can come with ready-made experiments, but maybe we can come with a discussion that turns into an experiment around the table. And if there are people who would be interested in contributing to that discussion / bring a laptop and hack something up and see how it works, I would be interested to hear from you on the list. With that, are there any other? Sorry, Ian, I misinterpreted your "I'm being kicked out of my room" to your "I'm not coming back." So I'd actually started closing the meeting. I am glad that you found another room fast enough that you did not come to an empty room. Martin.
Yeah, on issue number 5, I remain a little confused about the directionality of this. I mean, my perception of this entire problem space was this is usually a server-client problem, right? So as a client, I don't necessarily know a priori, is the server going to be able to send this stuff? I almost certainly don't know, like what traffic's going to deliver. So like as a matter of policy as a client, I should probably send the transport parameter that says I'm willing to accept SCONE headers, unless I'm just absolutely sure this is not video and that it's a non-compliant server. So it seems like there is a client-initiated signal that should be sent almost all the time in the form of the transport parameter. And I guess I don't know what we're talking about.
I think Matt is going to come answer the question.
Lovely.
Yeah, I think you need to read the issue, Martin. Like the history here is that yes, the information is there on the wire, but it's there in an inconvenient spot for a network element. Okay. So like it's in a transport parameter, but that transport parameter is buried in the client's quick initial, which is encrypted, and then it's in a TLS extension carried in crypto frames. And so like in order for a network element to see that a client is intending to try to use SCONE, it has to do a bunch of work. And that work is essentially identical to the work that has to be done today to apply SNI-based classification, right? Because it's doing the same thing, and it digs into the quick initial to extract the SNI out. And that is relatively onerous. And so the idea with an indication is if you're going to have that information anywhere, put it in a more convenient spot so that the network element has a reason to, try. Whereas with the way we have it today, there's basically not a real advantage because they're going to do the same amount of work at the start of a flow. That's basically the idea.
Thank you for that clarification. That partly answers my point, but I guess even if I have this indication, like it's whether anything happens is dependent on the server actually supporting SCONE. So it seems like this signal is at best speculative on whether SCONE will actually be on the connection. Right?
Yes, it is speculative, but like in reality, I would posit the majority of traffic on the internet by bytes is from situations where the client and the server have a priori knowledge about each other and have a very good certainty about what is going to happen. So like this is the case for the YouTube app. This is the case for the Facebook app. This is the case for the Instagram app. We connect to their clients that connect to known servers that have known capabilities like 99% of the time. So like, yes, there are many cases where that is not true, but there are also lots of very compelling cases where it is true, that you kind of do know what's going to happen.
Okay, I think that makes a lot of sense, although it's really quite contrary to a lot of other people have been saying about I don't know what my flow is going to be. But okay, I'll sit down. Thank you.
And it sounds like clear, it's like if you have a generic browser case, yes, that is true, but that's not like all traffic, right? It's not all traffic is like what Brian said, 90s style like internet web browsing where you have completely unassociated entities. So that's just not the internet we have anymore.
And I am not a browser engineer, but I'm assuming that a lot of the traffic for even in browser like video traffic, there's some JavaScript somewhere that knows that it's talking to a video server as well. It's just that that's well after, like, this gets to the early indication discussion. That JavaScript loads well after the connection is established, right? So like that's sort of where the timing comes from, at least in my understanding. Anyway, Marcus.
Yeah, I just wanted to add one point. Like even if when you have the case that you will have a non-compliant server, the consequence of this is that the network might initiate this two-minute throughput measurement thing, and might fall back to throttling. I'm not sure that that is the consequence that we have to kind of accept by doing this, and if that. So even getting this wrong sometimes probably isn't that bad for most browser flows. Just saying it. So and why we then need the early indications is that I think operators will, for flows that they do not see the indication on, they will likely try to do DPI for some time being, because there might be video services there that are not SCONE capable, and then waiting 2 minutes for those to adapt is probably not an easy sell for operators, at least at this early phase. So yeah.
Alan.
I think at the very end of what Marcus said, he answered the question that I was going to ask, which is what happens if the clients aren't sending this, what's going to happen? And it sounds like it means they're going to, the CSPs are going to fall back to their existing logic. They're going to have to do DPI. They're going to try to extract the SNI and say, like, I think this is probably ABR video, and therefore I'm going to like do stuff to it. And so I don't know, this goes to our previous discussion. This is sort of a transitional problem. Like, I think there's the people who send video have incentive to like opt into this because we get better QoE out of it. And throttling is bad. My comment on the issue has been up on the screen for most of the time, which is that like we would really like to coalesce all of our traffic onto a single connection if possible, but we don't want that connection throttled.
Right.
Just because there are some ABR video flows and there's all kinds of other stuff that I don't want throttled or shaped. And so like this assumption, like in the past, we have separated our video VIPs from our non-video VIPs for some apps. And that makes it really easy for CSPs to say there's video here, but we don't want to do that anymore. But we cannot do the thing we want to do unless we can get rid of the shaping. So the more ways in which we can reduce the assumptions that there's like, this for tuple always has ABR video on it is like not a good assumption that we want to be able to go forward. We want to get away from that.
Cool. Thank you very much. Waiting for the queue to come back, and then I will go back to the where we were before Ian came back to us. Does anyone have any other business they'd like to discuss in our remaining 11 minutes, or would we like to take 11 minutes back? Rinjie?
Yeah, Brian, just a quick question for you. What do you expect to happen at the Madrid IETF hackathon? Do you expect us to sort of have like a proof of concept implemented, do some interops or things like that? Just curious.
If we had proof of concepts implemented that we could do an interop on at the Madrid IETF hackathon, I would be thrilled. I don't know that we're there, but if you're more optimistic than I am, then great. It sounds like there's probably going to be a track of people who want to do experimentation / simulation / experimentation planning around these windows. That would be one topic. If there are people who have implementations that they'd like to test and interop, though, that would be Yeah, that seems maybe a little aggressive to me, but like, don't let me say no, you can't possibly be ready if you have code to bring. I do want to take some time at our next interim, which is the other time slot during the day on the 2nd of July, to do a little bit of the planning for the hackathon. Don't gate on that though. If there are things that you'd like to bring to the hackathon, please do take that to the list. I should take an action item to make sure that we actually get a table at the hackathon. It's been a few years since I did that. I understand there's a little bit more prep that they'd like to see now than the last time I was at one. So thank you for the question. Any other questions or business? Going once, going twice. Thank you all for joining, especially those of you in inconvenient time zones. I think we made a bunch of progress on knowing what we know and knowing what we don't, thanks to Anoop and Marcus. And we will see you all on the list and at an interim in 3 weeks. Bye all.